The derivation sheet serves as the essential analytical bridge that transforms abstract concepts into a tangible understanding of physical reality. Its significance lies in its ability to take a complex, tangled mathematical relationship and break it down into intuitive, manageable pieces that describe how the world actually works. Mapping the transition of understanding, the state diagram. As illustrated in the state diagram, the derivation sheet is the engine behind every purposeful transition in the learning process. From theory to intuition, it begins by providing the formal proof that allows us to move away from mere symbols toward a physical interpretation. It defines a double-swirling effect not as a mystery, but as a balance between two simpler geometric actions. Stretching, how a field pushes outward, and diffusion, how a field smooths itself out over time. From intuition to verification, this structural breakdown is what makes interactive exploration possible. By defining specific parameters like source strength and vortex strength, the sheet provides the instruction manual for users to manipulate digital models and visually verify that the math holds true in a simulated environment. Guiding the researcher's journey, the sequence diagram. The sequence diagram highlights the sheet's role as a roadmap for logical progression. The workflow of discovery. It tracks the researcher's path from the initial analytical proof through to the final physical manifestation. Without the derivation sheet, there would be no framework to connect the stretching of a fluid to the way light moves through a vacuum. Active interaction. The sheet facilitates a back-and-forth dialogue between the user and the concepts. It allows a student to ask, "What if?" by adjusting sliders, using the sheet's underlying logic to see how the total curvature of a field responds to different physical pressures. The master key, uncoupling the universe. The most profound significance of the derivation sheet is its role in uncoupling the fundamental forces of nature. In their natural state, electric and magnetic fields are locked in a complex feedback loop where one constantly creates the other. The derivation sheet provides the unique mathematical tool needed to break this loop, allowing us to view each field independently. This uncoupling reveals a stunning physical truth. The spatial curvature of a field is directly driven by its own acceleration through time. This insight, as shown in the final stages of both diagrams, is what ultimately allowed for the discovery of the speed of light and the creation of 3D visualizations that show light as a self-sustaining wave propagating through the void. Ultimately, the derivation sheet turns a static page of calculus into a dynamic lens through which we can observe the self-sustaining rhythm of radiation.